So hi everyone, thank you for joining this session. So we are in the final session of this particular version of the training. We are in module 4 and the fourth session of module 4 within security. Today we're going to talk about seamless connectivity and Hotspot 2.0 and open roaming. We're only going to touch about the basics of these areas. We're not going to go into a lot of detail, at least introduce the idea and the concepts and the various terminologies is basically what we're going to talk about today. So before we get into today's session, let's just quickly recap what we talked about in the last session. So last session was quite exciting, and we talked about attacks and vulnerabilities in Wi-Fi. Our team, Sainath and Gopi, went through many different types of well-known attacks in the Wi-Fi world, and at the end they also talked about how we can prevent certain attacks by using certain methods. So the most common attacks that we have seen, we talked about, are the passive attacks, where we are doing eavesdropping on an existing Wi-Fi network. Someone can just scan a network and collect useful information from open networks. So that's a very simple, very common way of creating attacks. Then of course there is wireless jamming, where you can jam the RF signals using some form of a high energy signals in the same frequency band, and that can jam the Wi-Fi signals, cause high interference and disrupt connectivity. There is also this concept of rogue access points. So someone can basically set up an access point in the same area where you have your Wi-Fi network, and they can attract you to connect to their network and basically create an unauthorized Wi-Fi access point that can possibly you can connect to, and then the attacker can try to steal information that way. Of course, we talked about cracking of WPA keys and also web keys and dictionary attacks and things like that. So how the process of those attacks work by cracking web keys using a brute force method, where you go through a series of like thousands and thousands of passwords and try to reverse engineer the process of and then you use a trial and error method to find out the actual keys. And there is we explained that in a little bit of detail. Then we talked about evil twin attack, where you can actually create a twin of the legitimate access point that's on the network. We can actually copy its SSID and its details, and then we can create the attackers can create an evil twin which looks exactly like the authorized access point, and then it somehow encourages the devices to basically connect to that new access point. So basically you could deauth the client from the existing access point, and when it reconnects, it can connect to the evil twin, and then the hacker can then steal information that way. There are of course denial of service attacks like deauthentication, disassociation attacks, where you can take a valid network connection and you can flood it with the deauthentications to make it look like the AP is deauthenticating the client, or the client is deauthenticating the AP, and then you can create denial of service attacks. There's also man-in-the-middle attacks, replay attacks, and so on. These are all the things that were discussed in the last session. If anyone missed that, that recording should be up on the website now, so you should be able to go watch it. Okay, so jumping into today's session, it's a slightly different area of security. We're not really talking in detail about the security itself, but it's very much related to security, and that's the reason why we put this topic in this module. So far, everything we talked about security is about security in a single organization or a single location. So if you consider your house as an organization or a location, then the WPA personal authentication is about how do you make that one location secure, and how do you make sure all the devices that are connected in that one location can get access to that network in a secure fashion, and how can you make sure that the other devices that are not supposed to be there do not get access to the network. But the problem is around that one region or one location or one organization. If you take an enterprise, now we have more enterprise-based security methods. There are many access points involved, and possibly multiple sites in an enterprise. There could be multiple buildings, multiple locations for the enterprise across various geographical locations, but it's still a single organization. And security is the problem of enterprise security is handling with the security within that organization. So which means that there could be only one server entity and one entity that is doing the identity check of the devices. There could be a radius server or some form of identity server on their network, on the company network, and all devices that are connecting to various access points within the organization are still within that one organization. And the security is all about how do you make the devices that are within that organization more secure, right? And so that is what we have talked about so far in the first three modules. But that is not necessarily how the world works, and we of course go outside our organization. So if I have my mobile device, when I am in my home, I am in my home, and when I'm in my office, I'm in my office. But I'm also going to other places. I'm going to like shopping malls. I'm going to a number of other places, and it's the same device that I'm carrying. And this device is actually handing off or moving between multiple wireless technologies and between multiple networks within the same wireless technology. And you can think of all of them as different organizations that are managed differently, that have different security credentials, that have different ways to check identity, that we have different ways to log in users. And every organization or every venue that you go into has different methods in which they admit you into that organization. Now, this problem does not exist if you are within your organization. If you are within your enterprise, let's say you have your office in India and you have a Wi-Fi network. So for example, in our office, we have Candela office network, right? So that network I have here. So last week I went to our Bangalore office, and we have the same Candela India network there. Even though it's a different physical venue, my phone would automatically connect to the Candela office network in Bangalore, even though I'm now at a different location, and it's the exact same network, and it's managed the same way. So even though there are two physical locations, it's still part of the same organization, and it's still part of the same network. And that's how normal enterprise security works. But now if you look at as you cross the organization boundaries, how do you get the seamless connectivity? How do you get security? Is the problem that needs to be solved in a day-to-day life. And that is where technologies like Hotspot 2.0 and OpenRoaming and these things come into picture. So if you take an example of the day in the life of a mobile device, so let's say you are in your home, you're connected to your Wi-Fi network, and you're using Wi-Fi from a mobile device. So let's say 8 in the morning, you get into your car and you start driving to your office, and you want to listen to some music. Of course, there is no Wi-Fi there, so on the highway. So you would of course switch on to the LTE network, and then you would use the LTE network. And then as you move to the office, now you're connecting to a different Wi-Fi network. So your home SSID, your home Wi-Fi network is different from your enterprise SSID, your enterprise network. So now you need to use a different network to connect to. And once you're done with your office, maybe you take a walk after lunch. Now you are outdoors. You don't have access to the office network anymore. Now you're connected to the cellular network again. And then maybe in the evening you go to a restaurant for dinner, and then now you have options of LTE and cellular and so on, right? So as you move from venue to venue, from organization to organization, the way you connect to the network, how you use it, all of that completely changes, and that makes the connection process fairly tedious, right? So especially if you take an example of let's say you want to you're visiting an airport, you're about to travel, and then you want to connect to the Wi-Fi network in the airport. Connecting to the network is a pain point. So you need to actually go find a particular airport SSID, then you need to click on it, then you select it, and then it shows like a captive portal page. Then you need to put in some information, and then you connect to the network. And when you go to different venue, the process could be completely different. And none of these things are secure. Not only is it time consuming to onboard your onto the network, none of them are using any security, right? Once you connect to the network, you are using open authentication, right, at that point, and the connection itself is not secure. And these are the things that will discourage people to actually use Wi-Fi more in public venues, right? And so improving this seamless onboarding and making it completely agnostic to the user is something that is considered to be very important for even more widespread adoption and usage of Wi-Fi. Now, if you look at your cellular network, how it works. So let's say I have my phone here, and let's say I'm in India today, and I'm connected to Airtel network in India. So tomorrow, let's say I fly to the US, and I turn on my phone there. Now I'm connected to the AT&T network. So I don't have to do anything. My phone will automatically connect to the AT&T network because AT&T and Airtel possibly have some partnership, and AT&T could possibly be the roaming partner for Airtel, and the partnerships are already established. And as soon as my phone is turned on, it will automatically connect to the AT&T network, and all the accounting and authorization and all the billing and everything is all taken care of seamlessly for me. I don't have to do anything. And that is how cellular networks work as you move across locations and venues and so on. That does not happen today with Wi-Fi in most cases, right? If you're using going to the airport, you just, again, you have to physically select a network, connect to it, and that discourages people from using Wi-Fi. So if you want Wi-Fi to be more widely adopted, then you have to make this connectivity seamless and also more secure. The other problem is that there are a lot of venues that offer these Wi-Fi networks. So if you go to a coffee shop, if you go to a shopping mall, if you go to some place like that, they offer these Wi-Fi networks. But for people to use them, they want people to use their Wi-Fi network. So as people connect to their Wi-Fi network, then these venues will have more visibility into what the users are doing on the network. And they will be able to push smart advertisements, location-based advertisements. They should be able to track number of people coming into the shops, when they're leaving, when they're coming, how long they're staying. They should be able to track all this information, and this gives them more visibility about the number of users on the network. So it's in the venue's best interest to make sure that the user connects to their network rather than stay on the cellular network when they're inside the venue, right? It is in their best interest, but again, that is not happening. The main reason being the connectivity is not seamless, the onboarding is not seamless, and the connectivity is not secure. So the idea is to really solve these problems, make the connectivity seamless and also secure. And the other challenge here is that there is a technology where you can use this mobile device and use both your cellular network and your Wi-Fi network at the same time, and that would increase your bandwidth. So let's say you're getting a certain amount of bandwidth on your Wi-Fi network. There's also cellular network available. So if you want to do something called as multipath, where you're using multiple networks simultaneously, or multi-carrier aggregation is what is called in cellular world, but you want to do carrier aggregation across LTE and cellular and Wi-Fi, cellular and Wi-Fi, that can also be done if these particular systems work together in a more seamless way. So technologies like Hotspot 2.0 and all of that are really trying to solve this particular problem for us. So at a base level, the technology is really called Wi-Fi Offload, and it's really for cellular providers to offload onto Wi-Fi. And as we all know, the amount of bandwidth usage on the wireless networks is increasing exponentially, and more bandwidth requirement is there. People tend to watch movies from their phones when they're driving or when they're in a public place and so on. So the cellular networks are not really equipped to handle that amount of traffic, and it's very expensive for them to use licensed spectrum. So the cellular networks are constantly cellular network providers are constantly trying to offload as much traffic onto Wi-Fi as they possibly can. And some of the data shows that already 50 to 60% of the traffic from cellular networks is offloaded onto Wi-Fi in many locations. And a lot of data shows that about 80-90% of the fixed wireless traffic that we're getting, that bandwidth usage, is on Wi-Fi, not on cellular, right? And it is heavily used. So carriers try to offload onto Wi-Fi. So a typical connection for a carrier would be where the phone connects to the cell tower, and from the cell tower it connects to the basically the phone network which is behind the cell tower. But when the carrier is offloading, the exact same phone with the exact same user credentials, the exact same SIM card, can now seamlessly connect to a Wi-Fi network that is inside the venue, and then basically from there you connect to the IP network, and then from there you basically move to the phone network, the traditional cellular network on the back. So that is called carrier offloading, where you actually offload the device from a cell tower to a Wi-Fi device. How can we do that seamlessly, right? Is what we're going to discuss. Before we get into that, let's talk a little bit about hotspots. I mean, most of you know this concept of hotspots. Everyone who has used hotspot technology in hotspots in public venues, you go to Starbucks, you go to a coffee shop and things like that. You are using these hotspots, and the number of hotspots is continues to increase at a very high rate. If you can see some of these graphs, it shows that there are almost 12 million hotspots in retail, in the retail space, right? And then there are cafes, restaurants, healthcare facilities, airports, and so on. And there are literally millions and millions of hotspots all around the world. And what is a hotspot? Hotspot is basically a public location where there are a lot of people going to be there. Either they're already there or they're going to come and leave, and it's like a busy place where there is really how can you actually bring all of them together and make the connectivity and roaming seamless. So to do that, we use this technology called Hotspot 2.0, and the Wi-Fi Alliance also calls it Passpoint from a certification point of view. And the Passpoint certification is about certifying both the network elements, which means access points, and also the end user devices for compatibility of Hotspot 2.0, right? So that's part of the Passpoint certification. So without Passpoint or Hotspot 2.0, this is how an access point will, what the access point will do. The access point will advertise in its beacons its SSID and some form of security. It could be enterprise security, or it could be just the personal security methods, right? But with Hotspot technology, when the device and the access point are certified for Hotspot, in the beacon itself, the access point will advertise a number of other informations, like what kind of networks that are available that the user can connect to. Remember that even though the hotspot is a Wi-Fi access point, that network, that access point could be provided by the cellular network provider. So the cellular network providers have base stations and towers, but they can also have these access points in these venues. Either these access points belong to the cellular network provider, or they have some form of agreement or a contract with the venue provider. So as an example, let's say we have a chain of coffee shops, and maybe the coffee shops are all having their own Wi-Fi networks that they provide to their customers, but the major service provider like AT&T or in Verizon or the US, or Airtel or Jio in India might have some form of an agreement with them and say all your coffee shops should advertise my network on your access points. So basically the service provider is using the existing network infrastructure from the venues, or they can set up the infrastructure in the venues. So an operator like Airtel, Reliance, or AT&T, someone can actually come to these coffee shops and set up the network itself. Either way, the idea is that there is existing network infrastructure in all these hotspots, and you advertise the various networks, and the same physical access point in the hotspot can carry access to many different networks, right? So you can advertise 4, 5, 10 different networks on your physical access point on your hotspot. So and also it shows information about is that particular network free, or is there a fee, what kind of internet speed you can expect, what type of venue this is, what is the name of the venue, who are the roaming partners, if that is your home network. So let's say you are on, let's say I'm on an Airtel network. When I connect to the hotspot, if there is an Airtel network advertised, then that's my home network. But there could be other networks also advertised that are my roaming networks. So I get a list of all the networks that are available, and that allows my phone to go connect to one of the network. Even though at a air interface level, I'm still connecting to the Wi-Fi network, and I'm still accessing the network and sending data through Wi-Fi, I am actually authenticated with the service provider network, right? Because it's the same authentication mechanism that I use when I connect my phone to the cell network. The same method is used when I'm connecting to the Wi-Fi network. But only the wireless medium technology I'm using is changing. Everything else stays the same. And this allows us to do seamless transition from cellular network to Wi-Fi network. It's the end-to-end authentication and basically identification of the device is still the same. The security methods are still the same. It is just only the air interface medium has changed, right? and that is the only thing that that will change. So that will cause us to actually have seamless handover between Wi-Fi and cellular networks and Wi-Fi, and also between Wi-Fi networks at different venues. So advantages of Hotspot 2.0, of course, in the Hotspot 2.0, there is network discovery. So we need to discover the network. There is a registration process, there's a provisioning, and then of course the usage network. So advantages of Hotspot 2.0, public hotspots become easier and more secure. So once the authentication is done, all the traffic is encrypted. None of that goes over the air right now, unlike what happens in your airports right now. When you connect to an airport, if you're not on a hotspot network or on OpenRoaming network, then your data is not encrypted. But when you're on a basically Hotspot 2.0 network, all the data is also still encrypted. Encryption is mandatory and it provides high level of security. And you can actually bring multiple network providers together, and they can all work together to create a seamless mobility experience and seamless connectivity experience to the end user. So some terminology when it comes to Hotspot 2.0, there is some things that we all need to know. The base standard extension, that is from where Hotspot 2.0 came out, is called 802.11u, and 11u is a 802.11 protocol standard extension, and it is developed by IEEE for improving internetworking with external networks. So that's the idea. It's basically internetworking between various external networks that are external to each other and make that connectivity seamless. So that's the base standard extension, and from that all this technology came. And then of course we talked about Hotspot 2.0 is also known as Wi-Fi certified Passpoint, is based on the base .11u standard, and it is the Wi-Fi Alliance version of the .11u standard. And the other term you might want to know is something called as ANQP, or Access Network Query Protocol. And this is a protocol that is used for by the device and the access point and the network to exchange information about the various networks that are available. And basically, if you want to find information about the various hotspot, the various providers that are providing networks on the hotspot, the roaming partners, and all these other details, you can use the Access Network Query Protocol, or ANQP protocol, for that. And ANQP is carried over this mechanism called a Generic Advertisement Service, or GAS, which is basically a layer 2 transport mechanism to actually carry ANQP frames. Now, some of this communication needs to happen over layer 2 because when the client is connecting to an access point, at this stage, the client does not have an IP address and it is not connected at the IP level. So it can only operate at the layer 2 level as a part of the connection process. So generic advertisement service actually allows you to do layer 2 frames, action frames, that can actually carry the messages between the client and the access point and the network behind it, right? Without having to have any IP connectivity. So that is where the generic advertisement service, or JS mechanism is used, and that's another common terminology. Of course, we all know 802.1x, which is part of the Hotspot 2.0 terminology. We studied about this in the previous sessions. We talked about EAP, we talked about radius servers and AAA servers. They're all part of the Hotspot network and ecosystem. And of course, we have these identity providers, or what we call as IDPs. And these are basically the providers that are providing the identity check for all the users that are connecting to the network. So these are the most common kind of building blocks and terminology about Hotspot 2.0. Now let us see how it works. And I'm not going to go into a lot of detail here. I was hoping to have a bunch of capture files to show you how this whole connection process and all of that works. I could not find it very easily and could not generate those things in time, but maybe we'll post it later and we'll show you some examples. But for now, I'm showing basically a simple beacon frame of 802.11u, or a Hotspot 2.0 enabled access point. Now, as we all know, beacon frames will have all these information elements. They'll have details about SSID, supported rates, ERP information elements, QBSS, HT, VHT, EHT information elements, and so on. Along with that, Hotspot 2.0 enabled access point will have these additional information elements. right? There are four additional information elements. These are the information elements that advertise the information about the various operator networks that are carried on that particular access point. Now, the operator networks could be cellular networks, they could be other Wi-Fi networks, they could be some independent third-party network providers, they could be MVNOs or multi-vendor network operators. There could be many different types of entities that are advertising their networks on top of the beacon frames. So the beacon frames will show you all these information elements, and the client device will read the information inside these information elements to identify what type of networks that I can connect to. When I say network, I'm not referring to the Wi-Fi network. The Wi-Fi network is a normal connection. I'm talking about the service provider network that is being advertised on top of Wi-Fi. So Wi-Fi is really used as only a carrier network to carry the main network that is being used, and that main network is more universal, and it is across many entities, and Wi-Fi is just a carrier network for them, right? So on the carrier network, we have all these information elements, the internetworking information element, interworking information element that has information about the different types of access networks that are available. Is it a free network, a paid network? What type of venue is this? And all these details are there. The advertisement protocol information element has information about ANQP, and if that ANQP is supported or not. There is a roaming consortium information element that gives you more details about all the roaming consortium and all the partners within the roaming consortium, all the operators that are advertising their network capabilities in that consortium is all listed in these information elements. So when the client sees the beacon, now it has a lot of information about all the different types of cellular networks and other network operator networks that are available on this physical access point. Now, remember that when we are doing enterprise Wi-Fi, we were only advertising that company's network on the access point. Now, with this method, you can advertise networks from many different organizations, many different entities on the same physical access point, and that gives the option to provide connectivity to the device. So once the access client sees the beacons and sees all this information, then it can decide to connect to one of these networks and get more information. And for that, we use the access network query protocol. And the access network query protocol will have basically it's just a request response kind of messaging. And again, the client will send information about it will query for information about a certain type of venue, certain type of authentication method, certain type of network it wants to connect to. All those details it will ask for, and then the access point will go and find these details from the network and then report it back to the client. And then and once the information is achieved, the client can then decide which particular network to connect to. Does it want to connect to the home network or maybe a roaming partner network? And then once that particular decision is made, then you go through the standard .11 association process and .1x authentication process, and then four-way handshake process, and then data exchange. But in this case, most likely we're using, if you're using like a cell phone that has a SIM card, then we use an authentication method called ePSIM, which is basically a SIM-based authentication method that is used for connecting to the Wi-Fi network also. Or you can use other kinds of authentication methods as well. Right? So the ANQP messages in exchange information will have all these details, and it will have a number of information elements. It will have capability information about the network, the roaming consortium, the venue name, the geographical location, and so on. And those message exchanges are really done before the client device will figure out which network to connect to, and then it goes through the connection process. As I mentioned, we have this generic advertisement service, which is basically an 8.11 management frame. It's actually an action frame. So this is called a public action frame. So we all know that in Wi-Fi we have management frames and control frames and data frames. Under management frames, you also have this some action frames. Under that, there is basically a public action frame, and this frame will carry the ANQP messages over the Wi-Fi air interface. And it's the same again, it's a request response message that carries the ANQP messages basically. So this is really how the end-to-end process works. This is a slide from, I think, one of the Aruba white papers. So there is basically the discovery process, the authentication process, and the access. And these are all what you have on the top is all the parties that are involved in this particular whole process. The first basically a party involved, or the stakeholders involved, is the client device itself, the client that is connected to the network. And then you have the Wi-Fi network provider, which is the access point. And then you also have the wireless LAN controller, and then you have the radius server, and you also have the operator network. So if you have a cellular operator, the operator network basically has a home location register HLR device that is also part of this particular particular set of devices that are used for the connection process. Now, sometimes the identity provider who is actually providing the identity can be the operator, or it could also be basically it could also be handled by the network provider itself. Like, for example, let's say in this case, Aruba is showing this idea of clear pass access management, right? So the companies that are providing these Wi-Fi networks, access points, and controllers, they can also do the identity portion as well by using certain methods where they are doing the identity check on these devices. Or you can, of course, have the real network itself, the operator network that is doing the identity check, right? And in that case, it is done by the operator's home location register, which is basically tracking the movement of the mobile device across various networks. So initially, let's say this mobile device is on the cellular network, it authenticates the cellular network, and it starts sending information on the cellular network. When it moves to the Wi-Fi network, again, the same device now has to authenticate with the same home location register which is on the network, and then it can get the same credentials and same connectivity, right? So discovery process is where you actually look for the beacon, and then you do the ANQP query, ANQP response, and so on. After that, there is a .11 association, and once the .11 association is done, you initiate the EAP handshakes, and you can do SIM-based authentication. There are two methods here, EAP SIM and EAP AKA are the two EAP methods. So you use the EAP method to actually authenticate with the server, the radius server, and then the server also has to authenticate with the carrier network, because remember that the authentication is not with the radius server, it is with the carrier network. So the carrier network is basically onboarding this device, and the carrier network also needs to track this device for accounting purposes and billing purposes, right? So the AAA server on the network needs to also go and check with the operator network and say, hey, can I admit this particular device onto your network that is hosted on my Wi-Fi access point? And if the operator network says yes, you can admit them, then basically then you get a response, and then you will finish the EAP authentication process. And then at the AP level, the IP address is assigned. After you do the basic connection process, IP address is assigned, and then you start accessing the internet. All of these things, the discovery, authentication, access, is all done in a seamless way. As a user, you will not know any of these things. You'll automatically move from, let's say I'm on an Airtel network, and let's say Airtel is also advertising its networks on public hotspots, on Wi-Fi hotspots. Then I don't even know that I moved from the cellular network to the Wi-Fi network. I was connected to the Airtel network on the cellular network, and now I'm connected to the Airtel network, the Airtel logical network on the Wi-Fi network. And at the end of the day, it's still the Airtel network. It's just the wireless carrier is changing, and I don't even know about it. And all the discovery, authentication, access process is all handled seamlessly through the connection process. Now, we're not going into details of exactly how all of the technology works, and I'm sure there is lots of material that is available online. The goal of this presentation was to really only introduce this concept to you. And anyone interested can, of course, go read more about it. Now, this is Hotspot 2.0, and it's been around for many years now, and it's widely adopted in many places. Although it is not, I would not say like fully adopted in everywhere. Even now, when I go to airports, I'm not using Hotspot 2.0. At least in India, I'm connecting to the airport Wi-Fi network, and I'm using some form of a cap to portal mechanism or something like that. So it's not widely implemented. It's widely adopted, but it's not widely implemented necessarily. And so there are organizations like this OpenRoaming as a part of Wireless Broadband Alliance, and and some of the other members coming together, consortiums coming together to create this open roaming federation, or where you can actually have a consortium or a federation where many people, many stakeholders can become members, and then create seamless roaming between many different venues and so on. So the stakeholders really are the venues that are providing the network access, like the coffee shops, the shopping malls, and so on. The service providers and the IDPs that are providing the service and also providing the identity check. And then there is the end users, which is basically me, with my phone, right? And all of these parties should come together and become part of the open network for this to work seamlessly, right? So an example I can give is most of us are using UPI payment methods these days. So I have some various UPI method payment apps like Google Pay or Phone Pay or something like that. So what are these? What is happening here? So I have my device which has the app, the UPI payment app, and I have my bank, which is basically has my bank account information, and where I'm transacting with my bank, and I have multiple bank accounts, I have multiple devices, and there are multiple venues. So I'm going to a restaurant, I'm going to a grocery store, I'm going to various places, and various venues, places are accepting the various payment apps that are on my phone that are going and transacting with many different types of banks that are behind the network. So there are all these banks. All these banks need to be able to talk to all these venues, which need to talk to all these payment apps. And all of them have to work together seamlessly for me to get the experience that I'm getting. So today I can take any payment app that I have and go to any venue and basically make a transaction with any of my any places and do payment, which will go and transact with any of the multiple bank accounts that I have. And all of that can be done seamlessly. The only way this can work is if all of them come together and have some form of a mutual authentication and a strong authentication mechanism and a federation that handles all of that. So it's a similar idea here. Open roaming is the idea is where the service providers and the venues and the end users devices can all come together and create basically a seamless connectivity experience for the users, right? The idea of the advantage for the service providers is that they can monetize hotspots. They can actually offload the bandwidth hungry applications onto cellular networks, and they can extend the coverage into the Wi-Fi. The advantage for the venues is it's much easier to automatically admit the guest users. The guest users don't have to specifically try and connect to the network, and so they get more people connecting onto their Wi-Fi network. They get multi-vendor support, and they get some extra monetization as well if they want to charge some money or if they want to retain customers and so on. The venues get advantage, and of course the end users, you and me, get seamless connectivity and a more secure connection. So all parties are being able to be an advantage, and that is really what open roaming is trying to do. My understanding is open roaming started off with large companies like Cisco started doing this, and then eventually there is the Wireless Broadband Alliance and other organizations that are trying to kind of standardize this process. So this is how like an open roaming ecosystem looks like. I'm not going to get into all the technology behind it, but again, this is how the ecosystem looks like. We have the identity providers, the mobile operators, the cable operators, the ISPs. These are providing the identity for the and also the accounting and all of those things. And then we have the Wi-Fi network providers, the basically the venues and the operators, the airports, education side, colleges, restaurants, coffee shops, and so on. And then we have the end users, and then we have the ecosystem brokers, which basically provide broker the connection between all these entities, right? And they're all part of this consortium, and they're all coming together to actually come up with some standard way of making this mobility seamless and secure, and also take care of all the accounting, because of course it's important for operators and identity providers and all these ecosystem partners to make money. So they need to have proper accounting methods to actually to be able to monetize this effort, right? So the consortium really handles the communication and the the seamless connectivity between all these members. So that's the idea behind open roaming. If you look at how basically the open roaming system works at a very high level, like there is the open roaming provision device. So basically the device itself needs to understand the open roaming mechanism protocol, and then basically when a verified user enters the area of a Wi-Fi network with open roaming enabled, then basically the device sends an access request, and then the Wi-Fi network responds. The consumer device provides its identity information because it needs to have some identity that is accepted, which is can be user ID or some form of identity provided by the network. And then the user identity is then forwarded from the Wi-Fi network to the identity provider, and after the identity provider successfully authenticates and validates the user and confirms and sends a message back through the Wi-Fi access provider, and then at this point the user is verified, authenticated, and then begins to access the internet, and then this process is done without any particular user input, and all these entities talk to each other automatically and seamlessly, right? And that is the idea behind open roaming. It's kind of very similar to Hotspot 2.0, but it's the idea is to actually make it even more widespread adopted and even more easier to use. So that is a quick overview about Hotspot 2.0 and open roaming. And what we are trying to really address here is how can you make the movement of the device across multiple organizations seamless and secure. And technologies like open roaming and Hotspot 2.0 really help in bringing all the stakeholders together to make that happen. So here are some references. Most of this material is taken from the Cisco open roaming and also like .11u. There are some white papers from various companies. I only listed 2 references here, but I'll be listing more references before we publish the slides. So this is kind of the overview of this particular last topic, and hope you found this useful. We still have about 10-15 minutes left. I wanted to leave about 15 minutes to kind of summarize a few things. This is the last session of the first part of this course. So I just want to take a few minutes to summarize what we have covered so far, and also talk a little bit about what is coming next. And we also have an exam, and I'll talk a little bit about that for the next 10 to 15 minutes. So in part 1 of this course, initially my plan was to have all of this in one course, which was very ambitious because there were like 30 to 40 hours of material that was planned, and that is too much to do in one shot. So what we did is we took the first 16 hours and we kind of made it part 1, and then the next 16 hours will be part 2, which will come early next year. So in part 1, we are calling it Wi-Fi technology fundamentals, the basics, and then we covered we had 4 modules. Each module had 4 sessions, and so we started with introduction history to Wi-Fi. We talked about the evolution of Wi-Fi, the various Wi-Fi generations, how residential Wi-Fi, enterprise Wi-Fi evolved, the various applications. We talked about the entire Wi-Fi ecosystem and the life cycle of a Wi-Fi product, and from design, from ideation to deployment, and the various organizations involved. We talked about that in detail. We talked about the Wi-Fi network topologies, various ways in Wi-Fi is deployed, infrastructure mode, mesh mode, bridge mode, ad hoc modes. Talked about various backhaul mechanisms that are used, backhaul over cellular, backhaul over fiber, copper, satellite, and power networks, and so on. Deployment use cases, we talked about that. And then in session 3 and the first module, we went into standardization. We talked about how standardization process works, how the different task groups, study groups are formed, and how the entire process of creating standards and amendments. And we talked about the alphabet soup, explained those in details. And then the 4th session, in the first module, we kind of broke down the AP's building blocks. So we looked at the various building blocks of an access point. How does the PHY work, baseband, lower MAC, upper MAC, and various building blocks of an access point. We try to explain that in detail. So that was the introduction and history. The idea is to cover the high level of that. We did that. Second module, we went into the physical layer. We talked about frequency allocation, modulation, coding basics, MIMO basics, 2.4, 5, 6 gigahertz band, and various concepts regarding the file layer, how multipath works, how modulation, various modulation coding mechanisms work. We talk about very basics about how signals are, why do signals move in waves. We talked about that, those kinds of things. And then we went into multipath, we went into spectral efficiency, and we discussed those things in detail. And then the third session, we went into MCS table, 5 data rates. We went through all different concepts of how we can use number of spatial streams, different modulation rates, channel bandwidths, and various settings to actually get different phi rates. And then we explained the difference between a phi data rate and theoretical throughput and the various overheads that we have. We discussed that. And then we also looked at phi headers, PLCP headers, PMD headers. We talked about how energy detect and signal detect works, how clear channel assessment works, and so on. The third module, we went into Wi-Fi MAC layer. We went into extensive details about how MAC frames work and basic AP management control, what is beaconing, BSSIDs, passive scanning, active scanning, what are the capabilities of an access point. We talked about MAC framing, headers, data frames, management frames, control frames, and the details of all the header details. We talked about frame control, type, subtype, and number of other details we covered in that session. And then session 3, we talked about carrier sensing, medium access, how physical carrier sensing, virtual carrier sensing works. We talked about PCF, DCF mechanisms, random backoffs, interframe spaces, EDCA parameter sets, how QoS works, and so on. And then the last session, we talked about data transfer, aggregation, medium overhead. We said that 90% of the medium is utilized for overhead, and only like 5 to 10% is used for data. To improve that, there is this concept of aggregation. We talked about different types of aggregation, AMSDU aggregation, AMPDU aggregation. We talked about various things like admission control and so on. So we went into a lot of detail there. And then the last module, we touched on security, various security protocols. We started from the basics, how web works, WPA, WPA2, WPA3, enterprise, personal, captive portal, and many different types of security protocols. We went into that. And then we jumped into the basics of authentication, encryption, the various EAP methods, TKIP, CCMP, WPA2, WPA3, how .1x connections work, how the various EAP methods work, how key generation works, 4-way handshake process works. All of those, we covered that in detail. And then the third session, we went into attacks and vulnerabilities, the different types of attacks. We showed practical examples of how these attacks happen and how attackers launch these attacks. We showed some capture files and also some tools that are used to launch these attacks. And then today's session, we covered roaming and seamless mobility across multiple organizations. And all through the way, we try to basically show some packet captures, some practical demos. Some of the sessions had real demos as well. We showed the wireless LAN throughput calculator, and we showed some tools. We talked about Wireshark. We showed how to analyze Wireshark captures and so on. So all of that is across 16 hours of material we covered. And as a part of the session, I thought I would summarize this because we have the exam coming up. And all this material is uploaded on the website. The videos for all the sessions should be there. Today's sessions video also will be uploaded by tonight. And the slides will be there. We are running a little bit behind on the Q&A and also the notes, the class notes. We will try to upload it as quickly as we can, but at least the slides and the videos will be uploaded. All of the 16 sessions, slides and videos should be uploaded by tonight and should all be there for you to use to prepare for the exam. And so what is next? Next week, we are not going to have any session. We are trying to open this up as a kind of a interactive Q&A session. So next Tuesday, same time, whoever has time, you can log in. And if you have any questions about the course, or if you have any feedback, or if you have any thoughts of what we could have done better, or if you have any questions in general about any material that has been covered, you can join the session. You can ask. So it will be an open session. It will open mic. So whoever wants to talk can talk. I will not be presenting. Will not be presenting anything. Everyone can be unmuted and ask any questions or provide any suggestions or anything you want to ask. You can join. So we will be online for 1 hour next Tuesday between 4 p.m. and 5 p.m. India time, and anyone can join. And if you have anything you want to discuss, you can about the exam or about the material that has been presented. So next week, that's the plan. And the week after that, which is basically the 19th of December, we will have an online exam, and whoever is interested in getting a certificate can actually participate in this online exam. It will be again between the same 4 p.m. to 5 p.m. India time on Tuesday 19th. So just like you're connecting today at 4 p.m., you can connect at 4 p.m. And we will basically make an exam link live, and we'll give you like 45 minutes or 50 minutes to finish the exam, and the exam has to be finished within that time frame, within that 1 hour, right? And then we'll be and then the following Thursday we will be presenting the certificates to the people who did basically went through the exam. So a little bit more about the exam itself. I just wanted to provide more details here. So for those of you who are interested in receiving a course certificate, there will be exam on Tuesday, December 12th, which is basically 2 weeks from now, and then at 4 p.m. And then this will be an online exam which will have 60 multiple choice questions, and you'll have about 45 minutes time to answer that. So let's say our slot is from 4 p.m. to 5 p.m. We'll start at around 4:15, and then by 5 p.m. the exam link will close, and you'll have 45 minutes to answer these questions. And all questions will be taken directly from the material presented in the course. So basically all of them will be taken, and the questions will be equally distributed across all the modules and sessions. So on an average, we have 16 sessions and about 60 questions. Then we'll have about 4 questions, 3 to 4 questions from each session, basically, right? And participants will only be able to, unlike the quiz that you're taking right now, the quiz right now is very forgiving, because you can see all the questions, you can see all the answers, and if someone wants to really cheat, they can easily do that. But the exam is going to have a lot more restrictions around it. The participants will only be able to see 1 question at a time in the exam, and each question will also have a time limit, right? And after the time limit, if you don't answer that question, we'll move on to the next question, and the correct answers will not be displayed, and the user will be able to select the answer. And this is all done to avoid any kind of collusion or any kind of a method to cheat. And all questions will be multiple choice questions, and all the questions and the multiple choice options will all be randomized. So which means that everyone gets a different order of the question. So if you're person 1, the first question might be the 10th question for person 2, right? And the multiple choice options are also be randomized in the exam software. So that builds another layer of security. We're talking about security modules. Of course, we need to talk about the secure exam, right?
Hello, sir. Sorry for interrupting. So in the slide, in this current slide, exam is mentioned on December 12th. So next week we are planning to do interactive session, right? And exam on December 19th.
I'm so sorry, I got this wrong. So thanks for correcting. While I was talking, I thought I might have put a mistake. Thanks for correcting. Yeah, so it's December 19th. So sorry, thanks for correcting that. And yeah, so the questions will be randomized, and basically that's the idea of the exam. And then certificates, we are planning to give certificates to anyone who's interested in participating in the exam. So if anyone scores 50% or more, if you get at least half of the answers right, then you get a certificate of participation. And if you get like 70% or more, you get a certificate of merit. And if you get 90% or more, you get a certificate of excellence. And we'll put that on the certificate. We don't necessarily have to mention the amount of marks you or points you got, score you got, but we thought we'll have like 2 or 3 different types of certificates just to reward the people who have done a really good job, but at the same time also be more inclusive of the people who may not be able to but still would like to get a certificate of participation. So that's the idea behind the certificates. And there are no restrictions on attendance of the live sessions. So even if you've not attended any of the live sessions, that is okay. You can go attend this exam, and the material is all there, and the questions will come from the material. And we will specifically pick the questions from the material because we don't want to make it an unfair advantage for people who are already Wi-Fi experts. So if you pick some general Wi-Fi questions, then the people who are Wi-Fi, who have experience in Wi-Fi, should be able to answer them easily, and the people who are beginners may not be able to answer. So to be fair, we will pick all the questions directly from the material that was presented through all the 16 hours. So if you're preparing, going through the material and trying to understand everything, then you should be able to do very well in the exam. So that's the idea behind the exam itself. So as we said, it's going to be next week is going to be like just a general kind of meet and greet kind of week, and after that week we'll have the exam. So that's the idea. Since we have a couple more minutes, I want to talk a little bit about the following things. Like, okay, this course is, once it's done, we do have a plan to do a follow-up, like a part 2 of this sometime early next year. We'll try to poll all of you to see how much interest there is. If there is enough interest, then we'll try to do it. And there we're going to go into even more advanced topics. So we'll also break that down into like 4 modules, and we'll cover a little more advanced topics like access points, controller architectures, cloud controller architectures, and things like that. Features like RRM, enterprise features, QoS, mobility, PowerSafe. We'll go into Wi-Fi 6 features, Wi-Fi 6E, Wi-Fi 7, smart Wi-Fi features, mesh networks, how Wi-Fi monetization works, and then there are also troubleshooting modules where we talk about various troubleshooting tools, Wireshark analysis, Wireshark filters, and so on, and various analysis tools and things like that. And then we also want to talk about testing. Maybe we might allocate an entire module for Wi-Fi testing. So we come from Wi-Fi testing background. We have been doing Wi-Fi testing for the last 20 years. So we are not going to try and advertise any of our products. That's not the goal at all. This is a completely vendor agnostic kind of free kind of training or at least a tutorial platform. So we're not going to try and advertise our products or anything, but we are going to talk about Wi-Fi testing in general, and the various things that we need to know. If you're a Wi-Fi tester, how do you approach testing and so on. So all of those we plan to cover sometime early next year, starting early next year, depending upon the interest of how many people are interested in this. We'll do a poll, and we'll try to do that next year if we can. So that is a wrap for this particular part of Wi-Fi fundamentals training session. I hope you all found this useful, and we really enjoyed this a lot. All of us who presented this, who are in this team from Candela, it was a lot of work for us. Every session needed many hours of preparation, even though we kind of understand the concepts, but putting the material together takes a lot of time. But we did this mostly because we also want to learn. We also want to enjoy. We also want to I strongly believe that the best way to learn is to teach. So by teaching is the best way to learn. If you know something, you teach it, and you learn, you get better at it. And that is the reason why we're doing this. Hopefully you all enjoyed this, and that is all we have here.